Hello everyone. So today we'll see about the project called as Switchgear Cabinet Part Identification. Before that, let me introduce myself. My name is A. Spurti Rai. Currently, I'm working as a associate data scientist at AI Sprite. So today we'll see about Switchgear Cabinet Part Identification. We'll see what was the business problem, what was the objectives, what was the constraint, what was the different success criteria we had, and how was the workflow, and what was the result we got. Let us discuss this one by one. So switchgear cabinets are integral in electrical systems, housing components that control, isolate, and protect electrical equipment. Efficient and accurate part identification is vital to maintaining the quality and safety of these systems. So, the business problem is the manual identification and labeling of switchgear components is a difficult and error prone process, leading to inefficiencies and potential mismanagement of resources. So, it is very important to handle these parts with the care. We should not miss out which kind of part it is, which kind of cabinet part it is, so that we should not label it in a wrong way. So our main objective was to minimize errors in component identification and labeling. So the main key goal of the objective is to automate the identification and labeling of the switchgear components so that we reduce the manual error by 10 to 20%, which is our business success criteria. Business success criteria is to reduce manual efforts in identification and labeling by 10 to 20%. So what are the benefits of this? So we will improve the efficiency, optimizing the workflows, and enabling a more streamlined manufacturing process if we are going to achieve this objective. So now let us discuss the success criteria. As I mentioned earlier, the business success criteria is to reduce manual efforts in identification and labeling by 10 to 20%. What is the ML success criteria? Achieve a prediction accuracy of at least 90%. We need to be 90% minimum accurate while detecting the cabinet part. Let us see about this economic success criteria. Achieve at least a 10% cost reduction by minimizing errors. Since the work is happening manually, the error is quite high. The error rate will be quite high, which will in turn increase the cost, which will in turn they need to go back to their store or the place where they keep all these cabinet parts, and again they need to reshuffle all of it. Correct? They need to rearrange it. Instead of saying reshuffle, let me put it in this way. They need to rearrange all the cabinet parts. So this will take a lot of time. This will increase the cost as well. So we mainly need to reduce the time and we need to reduce the cost as well. Let us see what is the constraint. Minimize additional operational costs and minimize production delays. Since if the person who is dealing this manually, where they are identifying that particular switchgear part and they are segregating it. If the person identifies it as a wrong uh, component, then they need to again rearrange everything, which will in turn increase the time, which will lead to production delay. So this is a brief overview of the business problem, objective, constraints, business success criteria, ML success criteria, and economic success criteria. Since we understood a brief since we have a brief understanding about the problem. Now let us see how the solution approach could be. How the solution approach which we have done to achieve this, to overcome this problem. So this is the model architecture. This is a basic model architecture. So any project should have a basic architecture so that if there is any deviation from the flow, they can get back to the track. So this acts as a backbone of the project. Basically, it connects the data pipeline, machine learning algorithms, and deployment framework. Now let us see the initial step, that is business problem. We thoroughly understood what the problem is and what are the multiple objective or the solution the client is requiring. So now let us see the next phase, that is data collection. So in this phase, we need to collect the different different images of the switchgear cabinet components. The components which we are getting, all of them are a customized components. The client deals with the customized components. So your data could be mainly with the images or the specifications or other identifying features of the switchgear cabinet component. So now let us see how it will work if you are taking an image data. So whatever the data we are getting, we need to store it in the S3 bucket where we will be safely storing our data, a huge number of data in a cloud interface. Instead of storing it in our local machine, we can store it in the cloud interface. Now let us see about the data pre-processing. So data pre-processing is a critical stage when it comes to your workflow of the project. It involves data cleaning, resizing the images, augmenting them for better generalization, and labeling them correctly. So in this phase, initially, whenever we have the data, we will go with data annotation. To do a data annotation, you can go for multiple tools out there. You have RoboFlow, you have CPAT, you have Label Image, Label Me, V7. There are multiple sources using which you can just annotate these images. Annotating basically means you're labeling these images, labeling the parts in that particular image. So over here, since it is an identification problem, either you can go for bounding box or a polygon annotation technique. Bounding box will be an efficient since polygon will take a bit longer time compared to bounding box. We need to pay a lot of attention when it comes to polygon type of annotation. So using the bounding box, you can define any number of classes as per your requirement. Once we have annotated our image, the next step would be splitting our data into train, test, and validation. So over here, it is good if we go for uh, 80 percentage for the training purpose, 10 percentage for the testing, and 10 percentage for the validation. Or else we can also go for 60 percentage for the training, 20 percentage for the validation, and then 20% for the testing. We can go with any ratio as per the requirement, as per the data, the number of data you have. Based on that, we can select this splitting ratio. Once you have splitted these data into this ratio, next step is data augmentation. In this data augmentation, basically we will increase the number of data set for the multiple conditions. You can add noise in that, you can add saturation, you can add brightness, you can add hue, you can rotate these images as per your interest with the multiple angles. You can add as I mentioned earlier, you can add noise to it. You can do multiple augmentation techniques so that you can basically make your data ready for the multiple conditions. Next comes the image resize. Every model will not take every uh, cluster of multiple image sizes. So it is very important you get all your images into a particular size frames. So once you resize the image, you can either download the data into your system, annotated data into your system, or else you can use the API URL if you're going for the RoboFlow or any other annotation tools. Once you have downloaded, you can save that downloaded data set into the S3 bucket itself. So this is a brief overview of the data pre-processing. Now let us see what happens in the model building. Let us see about the model building phase. So we have multiple algorithms. We employ supervised learning techniques here. Algorithms such as convolutional neural networks are ideal for image-based component identification due to their strong feature extraction capabilities. Okay, so in this case, we have used multiple YOLO models. Since YOLO is very good at identifying or detecting objects in the particular image, so we have gone with multiple YOLO models with the YOLO V8, YOLO V9, YOLO V10, YOLO V11, which is the latest version of the YOLO. Based on the data size, we have used these four YOLO models, and we have tried with multiple YOLO models. So we trained our model. We have received the best PT file as well, using which we can do further analysis. When it comes to model evaluation, once your model is being trained, you can evaluate your model using the validation data set. Here we could the evaluation metrics which we have used is accuracy, precision, recall, and F1 score, and MAP 50 and MAP 90/50. So these are the evaluation metrics which we have used, based on which we have evaluated either our model is performing well or not. Once we have a confidence that our model is performing well, we have saved our model, and we went to the deployment phase. After evaluation, the model is deployed into the production environment. So real-time integration ensures the model can identify components on the manufacturing floor or during inspections. So the deployed model integrates with existing factory systems to process images or data streams directly from equipment or operators. So this is a basic workflow of the entire project. Using the Flask, basically it is a user interface where user will have access to either they can insert a new image, so that we identify what kind of component it is. So now let us see how does our data original image will look like and how our detected object will look like. So over here you could see the first image basically shows the original image, whereas the second image shows the detected image. Over there you could see the bounding box as well, above which, where it shows the name of that or the class which to which it belongs to. Basically, this particular cabinet part, switchgear cabinet part, belongs to cables management bracket class. 0.96 basically gives us the confidence score that yes, this your model is 96% sure that the detected object is cables management bracket. So this is the output of the model. Finally, the user will be getting what is that particular component is, what is that particular component belongs to. So that is something, a brief overview of the entire project. Now let us see, when it comes to 360DigiTMG, what we offer to you, what we offer to our students. So we provide challenging real-time projects that push you to your limits. You will work with the real-time projects, learning all phases of project methodology. We have multiple phases of the project methodology. One we mainly follow is CRISP MLQ. So you will go through all these phases in detail. You will be able to practically apply it when it comes to the projects. Learning about different tools used in the industry like Python, Power BI, cloud platforms, etc. Work on research paper that are published in international journals. Our students who work with us in the real-time projects, they get a chance to get their name published in these research papers in the very well-known international journals. Access to various free tools to enhance your learning. So what are the different free tools we provide through our resources? That is, one is mind map. You will get a hierarchical structure of the each module, using which you will have a clear idea, you will have a clear understanding with your concepts. ML architecture assistant. You will have a basic model architecture. You will get the multiple options to insert the different values inside it. You can clearly observe how a end-to-end project works over there. Resume optimization hub. Whenever you go for the interviews, it is very important you abide by the job descriptions. So we provide the resume optimization hub as well, where you can just upload your resume and just check how your resume is relevant to how much your resume is relevant to the job description. Animated learning. For the multiple modules we provide the animated learnings as well. So this is a brief overview of the project Switchgear Cabinet Part Identification. Thank you. Thank you very much.